Hi, this is Dave Johnson with another edition of Math Off Topics. Today, I want to talk about the part two of my video series on polynomials. In part one, we showed that the leading term of a polynomial determines or dominates the behavior of the polynomial, and in fact determines the end behavior. In other words, the behavior of the polynomial as x goes to either positive infinity or negative infinity. In this video, what I want to do is show what those end behaviors are for a single monomial, and because the leading term dominates, all we really need to be concerned about is that leading term. So let's get into it. So I've written here a general form for a polynomial. Again, it's a sum of terms. Usually we write them in descending order by degree. So a polynomial of degree n would be a sub n times x to the n plus, and then other terms. Now, what I showed in part one of this series was that as x goes to plus or minus infinity, the polynomial will approach whatever the behavior of the a sub n x to the n. In other words, the first term. This is the first term of the polynomial. And so what we can say is that the conclusion is that the leading term determines the end behavior of the polynomial. Okay, now what is that end behavior? That's what we want to show in this video. So I've taken the liberty of drawing some graphs, and so we really have four different cases, and it's really going to boil down to if you can recognize these four situations in your polynomial, you'll be able to determine the end behavior. And again, we're looking at the leading term only. Okay, so the four situations are, suppose that n, let's start with odd. So if n is odd, in other words, it's an odd degree polynomial, like 1, 3, 5, 7, and so on. And in this case, if the leading coefficient is greater than 0, in other words, if it's positive. So we can think about, well, what's the most straightforward example of that? Well, a straight line, x to the 1, or x, which if it has a positive slope, so the leading coefficient would be positive in that case, it's going to start low, end high. In other words, it's going to go to negative infinity on the left and go to positive infinity on the right. But for polynomials in general, we may end up having some turning points or other behavior uh, in between. And so I represent those with what I sometimes describe to my students as squiggles, but again, they are turning points of the polynomial. And the higher degree the polynomial, the more turning points there are. So, but basically the idea here is that if n is odd, so if you have a odd degree polynomial and the leading coefficient is positive, then it's going to start low and it's going to end high. And that's the end behavior. And we're not, for this purpose, we're not that concerned about what happens for small values of x. We're only concerned about large values of x. Now let's go on. Let's suppose that we're still talking about n odd here, but what if the leading coefficient is negative, so less than 0? Well, we know from function transformations, and if you haven't had function transformations yet, don't worry. But if you think about the straight line with a negative slope, it's going to switch the positives to negatives and the negatives to positives. Okay, so in general, what we can do is we can say that the graph is going to look something like maybe this. So it's going to start high and end low. So odd degree polynomials start on one side, low values, let's say, and go to high values, or they start high and end low. So that's the end behavior. Now, what happens if n is even? So we have an even degree polynomial. So 2, 4, 6, 8, or so on. And let's suppose that a sub n is greater than 0. In other words, the leading coefficient is positive. Well, an example of that would be, say, x squared. So uh, the parabola, which has the routine shape, and it starts high, ends high, right? So, but for a general polynomial, we may have turning points in between. So I like to draw it this way. So let's say maybe it looks like that. Okay. We're not being specific about how those turning points look at this point. We're only interested in the end behavior. But if n is even and the leading coefficient is positive, it's going to start high and it's going to end high. That's what we mean by end behavior. Where does it start? Where does it end? For large values of x, either in the positive direction or the negative direction. And finally, suppose n is even, but the leading coefficient is negative. Well, again, we're going to switch. If we start high, end high for a positive leading coefficient, then we start low, end low for the negative leading coefficient. So it'll look something like this. Again, I'm just kind of diagrammatically representing the turning points, but in general, we're not too concerned about those turning points right now. We're only interested in the end behavior. And so again, if n is even and the leading coefficient is negative, it's going to start low and it's going to end low. I believe that this information is useful not only to college algebra students, but also to pre-calculus and calculus students, because you're always going to be running into polynomials, and it's very beneficial to know what those polynomials look like. So I hope this has been helpful. If so, please like and subscribe, and I will see you in the next video.